to speak here, and I'm here kind of in representation of the Sea Ice Prediction Network, so I want to acknowledge my authors, which are listed here, but also to all of our contributors, and I know some of you are in the audience. And I'm going to give you a little update on the Sea Ice outlook, where we're coming from, where we're at, and where we're hoping to go. So what is the Sea Ice outlook? And I hope by now most of you will know what it is. And if you don't, basically it's a collection of seasonal forecasts of September sea ice. We've been running this since 2008. And these are forecasts that are provided by the community to us, so we collect, analyze, and disseminate the forecast. We welcome all types of forecasts, including those from polls. We've even had high schools submit a forecast. And we request these forecasts 3 times a year in early June, early July, and early August. So the lead time of these forecasts, you see that it's about 1.5 to 3.5 months, so kind of truly in that kind of seasonal timescale. And since last year, we've also added a 4th call for forecast in early September. And I'll go into that in a little bit. We've normally or historically focused on sea ice extent, so that's basically one number per forecast. But recognizing that that's not of perhaps huge relevance to a lot of stakeholders, in recent years we've expanded to spatial forecasts of sea ice, variables such as sea ice probability, ice retreat day, ice advance day. So we're kind of expanding on what we're trying to forecast. Okay, so a little bit about the history. So why did we start in 2008? Well, this is purely one of those instances where an extreme case study and observations kind of triggers sort of this community effort. And so I think a lot of, this is actually the month I started grad school, was September 2007. And I remember back then a lot of senior cryospheric scientists kind of scratching their heads and thinking, oh my God, what's happened this summer? I think it was quite a big surprise. And as a kind of reaction to that, I think the community got together and said, well, let's see if we can forecast these sort of summer sea ice. And so for the first few years, it was quite a grassroots effort. And then in 2013, it kind of got crystallized into a bit more of a kind of official study. So this is when the Sea Ice Prediction Network got formed, and that's kind of the network behind the Sea Ice Outlook. And as the network has matured, we've added other efforts. For example, Alaskan forecasts. In 2017, we also had the Antarctic forecast, which Francois Massonet in the audience leads. We've also had Helge Gösling contribute the SIDFEX forecast since that time. We had some forecasts of opportunity for Mosaic during the summer of 2020. And also we created a sort of a parallel effort, was the creation of a data portal where we automatically ingested forecasts from the S2S archive and other contributors. And this was year-round, this data portal. SIPIN 2, which is the kind of current iteration of the Sea Ice Prediction Network, ends pretty much now. So we've run this year's forecast kind of on a bit of a shoestring budget at the end of the grant. And we have a pending grant for SIPIN 3 for the future, which I'll hopefully get to at the end. Okay, so the outlook has been growing. This is the number of contributions or forecasts every year from 2008 to last summer. And so you can see this is a positive message. You can see that the contributions have been growing. So our network or community has been growing. And the color-coded, the color codes are the different techniques of forecast. So you can see at the beginning that almost half our forecasts were what we call in heuristic, which is, I think, a fancy way of saying, kind of doing that, right? Seeing where the wind's blowing from and maybe making an educated guess. But you can see that in the second half of the period, most of our forecasts are either coming from more, like a standard or sort of rigorous forecasting techniques, whether it's statistical models or dynamical models. And in the last few years, we've had machine learning, which I know are part of statistical the statistical family, but you can see that the numbers increased in the last few years. And this is one of our kind of standard figures. This is normally our first figure in the reports, and these are just, this is a bar chart of the different forecasts, right? And so you can see that each single value here is a different contribution, and I'm sure you'll recognize quite a few of those names. And then the color coding is the type of forecasting technique that people use. And I want to point out kind of a couple features, right? One is that you see these colors mix in pretty well, right? And this is kind of something we see that generally the median forecasts are relatively similar, irrespective of dynamical or statistical technique. The other thing I want to point out is that the spread in these forecasts tends to be quite large. And here at the bottom, I'm showing you what a standard deviation of September sea ice extent looks like. The detrended is 500,000 square kilometers. And you can see that the difference between the lowest forecast and the highest forecast tends to be about 1.5 to 2 million square kilometers. Now, that's 3 or 4 sigma difference between your highest and lowest forecast. If you're thinking about a temperature forecast, that would be kind of, looking at your weather app on your phone and basically getting, different weather services saying, well, you're going to be 1 sigma or 2 sigma, either above or below, which is either, cold weather or warm weather. So, that's kind of an interesting feature that there is this much spread. This is for this year, for September 2022, and our median forecast is here in the dashed, which I don't have. Oh yeah, the number's about 4.56, which is probably going to be a little bit below what we're going to observe. Okay, so when we look at all the years, this is, and the median values with the observations, this is what we get. So in black is the observed time series of September sea ice extent since 2008, and in orange are the forecasts. And if your first sort of impression from this figure is like, well, that doesn't look awesome, you'd be correct. But let's put some more rigorous numbers on there. So in this figure, I'm showing you the root mean square error from 2008 to 2021 of the forecasts, and I'm splitting here kind of in 3. In blue, I'm showing if you take the sea ice outlook median, so you take all the forecasts and you use the median as your one forecast. That is shown in blue. The statistical models are shown in magenta. The dynamical models are shown in red. And the x-axis is lead time, right? So starting in June through to August, so your lead time decreases as you go to the right. You're getting closer to September. And then the 2 black lines, there's a continuous black line here that's flat. That's if you use the linear trend from past years to forecast that summer, right? And you can think of that as your kind of just simple sort of climatological forecast, but taking into account the trend. And that's you get a root mean square of about 0.6. The dashed black line here, that kind of starts at around 0.6 in June, but gets pretty good by September. That is using a damped anomaly forecast, right, on the first day of each month. And that's just taking the anomaly on, say, June 1st, July 1st, August 1st, September 1st, and then using the autocorrelation between those months and September, and just making your very simple AR1 forecast. And you can see that we're barely, we're either matching or beating it a little bit in June when we're using all sea ice outlook. So the multimodal forecast is at least on that trend line, but you can actually see the statistical and dynamical do not beat it. And these circles are from the one forecast we had in September 2021 for that September. And you can see that even though, there is a slight improvement from previous months, it really is not, it really isn't kind of approaching 0, which is, as your lead time approaches 0, that's where you want to be. Another feature we've noticed is that the error in our forecast is largest when the deviation from the expected linear value is largest, right? So basically anomalous years we're not capturing, but this is also, if you made a linear trend forecast, you get something similar, right? So it's kind of a characteristic of a system that doesn't have that much skill. Something else we've noticed, and I want to thank Francois and Larry Hamilton for leading this. The top is a similar version of the figure I showed before, so the observations and the sea ice outlook forecasts. They seem to be off by 1 year, right? So when there's a low year in observations, like 2012, the forecasts the next year are quite low, and vice versa. So there seems to be this kind of 1 year persistence between the observations and the forecasts. And when you line up the two time series, they do pretty well. This is pretty odd. You might expect it a little bit from dynamical models, right? So through preconditioning, right? So if you have a low year, you might expect pretty thin ice, and we know that the timescales of sea ice can be annual, especially in thickness, so you might expect that your forecast for next year will be low. But the funny thing is that this feature appears also in statistical models, and we know then in the observations, this 1 year correlation doesn't really exist in extent. So 1 year's sea ice extent, the correlation is it's very close to zero. So we don't really understand why this happens yet. But it's an interesting feature, but at least we can use the observations to forecast the forecast next year. However useful that might be or not. But it's kind of like, this thing we've discovered that we didn't expect it or understand it. Okay, so let's focus on last year, 2021. So this is the first year that we added this sort of pretty short lead time forecast. And historically, we weren't doing that because we thought, well, what's the point? By the time you get to September, the September 1st or the first week of September, you know pretty much what September is going to do because the decorrelation timescales of sea ice. But since we were noticing every year that there wasn't that much improvement from June, July, August, or that spread in the forecast was kind of pretty, it was remaining there, we're like, well, let's invite people to submit a forecast in September to see what happens. And so this is what happened last year. I'm clustering the forecasts just by the models that still gave us a forecast in September and the different color codes. And you can basically see that the spread across the forecast remains. There is a slight improvement, right? You can see the lines are the median values for each cluster of forecasts. And you can see that they're getting close to this observation in 2021, but that spread is still pretty massive. Let's look a little bit at what happened at the September forecast, right? So we made a very simple forecast, or you can use a very simple technique to put this forecast in context, right? So on the rightmost column here, I show you these are the outlooks that were submitted by the end of the first week of September. I think it was September maybe 9th that the deadline was last year. So these are the values, right? So we have forecasts from 3.7 or 3.8 down at the bottom to all the way to about 5.2. Now, on August 31st last year, we knew that the sea ice extent was about 5.2. And we just said, okay, let's use the tendencies from every Parsean observations to just get this kind of like, a statistical sort of estimate of where we might end up a month from now. And that's what I'm showing. These are, each single colored time series here is like starting with the observed value at the end of August last year with all past tendencies throughout the month of September. And if you take a monthly mean of those tendencies or those time series, you get this distribution. So basically, by September the 1st last year, you could have said, we're going to be somewhere in this cluster, right? Any value outside this distribution is going to require a never-seen-before September tendency. And you can see that basically 2/3 of the forecasts are outside that range, right? So they're just sort of outside what you might expect. And since I was thinking about this yesterday and remembering it was August 31st, I looked at the number for this year, 2022, and we're actually very similar to where we were last year on the same date by actually 0.1 million square kilometers more. So our expected value for September 2022 is quite similar to last year, but just shifting that distribution by 0.1. So it'll be interesting to see what we get this year. Okay, so we know that different models have different mean states, different climatologies, and we thought, okay, maybe part of this big spread is just, part of that spread, that climatology each model has. So maybe if we ask for, instead of forecasting the total September sea ice extent, we're going to ask for a forecast of the anomaly of sea ice extent, right? And that's the anomaly with respect to its model's climatology. And what I show you here is, we started this in 2021, and what I show you here are those forecasts in blue with black. Black are just the standard sea ice outlook forecasts, and you can see those are the left axis. And then the right axis is just, in blue, is just what those anomaly forecasts were. And I've lined them up so that the observed value, which was 4.92, and the observed anomaly, 0.7, are on the same, that same gray line. And you can see that the blue clusters are pretty much the same as the black clusters. So we did not correct for that model spread. So this is another pretty interesting value, right? That the models are also disagreeing in kind of what they're, within their own sort of climatology or their own model world, what the anomaly, is expected or forecast. And this is for this year, and we see, kind of a similar feature, right? That, we have some models forecasting a negative anomaly and others a positive, although they are, by August 2022, they are kind of converging into at least the sign. At least the sign is sort of, they're going for a positive anomaly. Okay, so another thing we looked at to try and understand these forecasts was the initial conditions. So we invited people to submit their initial conditions, and we had 5 different models. This is from 2020, and the last couple of years are similar. And what I show you in the top row are the sea ice concentration initial conditions. Hopefully you can read the initializations, so you can see most of them are late June or early July. And the bottom row is sea ice thickness. And if you compare the 2 rows, you can see that generally in sea ice concentration models agree, definitely at least where the sea ice edge is, but the thickness is quite different. And I think this makes a lot of sense because a lot of models assimilate sea ice concentration, but the sea ice thickness is still, we're struggling with that, both in terms of observing sea ice thickness, but also knowing how to include that information in the forecast. So this was for July 2020. The next month shows a similar feature. You can see, some of those models are super thin, and others are pretty thick, kind of around the same time. So then your next question might be, well, does this have an effect on the forecast? This is the sea ice volume, so integrating the concentration and thickness, both in 2020 and 2021 for the models that submitted these fields, and the x-axis, or where they are on the x-axis, is just when they were initialized, right? So it's from early June on the left to middle August on the right. And basically the main point is that even for the same dates, or around the same dates, you can see the different clusters. There's just a really big spread in how much sea ice volume those forecasts are getting started with. And then, so the next natural question is like, well, does it matter for the forecast? So if you plot, here it's a scatter plot of the sea ice volume at initialization on the x-axis, and then what each of those models is forecasting for your September sea ice extent, you can generally see, that they fall along a diagonal, that there's this sort of relationship, which is what you might expect, that if you have a larger volume, a more sea ice volume at initialization, you're going to forecast a larger sea ice extent. Okay, so kind of summarizing the sea ice extent scale in the sea ice outlook, it's modest, there's very large spread, and this seems to persist all the way to kind of like a pretty short lead time. And at least part of this spread seems to be related to initial conditions. Okay, so we know that sea ice extent is of limited value to stakeholders. So we've included the spatial fields I was mentioning earlier, and one of the main ones is the sea ice probability. So this is the probability that a grid cell has a sea ice concentration greater than 15% across for the mean of September. And this is kind of the figures we show, right? So if your sea ice probability is 1, it means that all the ensemble members are forecasting sea ice at that location. So you can see that, kind of like the bird's eye pictures that the models don't seem to do so bad. Like this is in 2021, and you can see the black contour was the observed sea ice edge. And this is, these figures, I think, or kind of forecasts can be quite relevant. For example, if you're shipping, I'm showing the shipping routes here on the bottom right. If you move on to the next month, you can see slight corrections in the forecast, but they're fairly similar. And I do want to point out that if you look at the multi-model mean In some regions, it does quite well, but for example, in the East Siberian Sea, the models are overconfident, right? None of them are forecasting sea ice probability in that tongue of sea ice that actually we saw in observations persisted through September. To put some skill numbers on these forecasts, I've calculated the Brier score, and that's just the difference between your forecast value and your observed value squared, and then you take an area-weighted average throughout the Arctic. So this is quite similar to the SPS metric. You know, you can see quite a bit of spread across the different forecasts. Again, the multi-model mean is the best skilled forecast, which is quite interesting. Now, if you use the last 10 years climatology, that's the black dashed, this dashed black line here. So, you know, it's still quite hard to beat like a recent climatology. And this isn't just a feature in 2021. We've seen that in previous years. But what we've also seen in previous years is that if you do use the multi-model mean, you do beat climatology. So there is skill in these models when you sort of taken them all together, which is quite interesting. This is quite similar, though, to what we found in the literature. This is a figure by Lorenzo Sampieri. So, you know, it's just really hard to make kind of these sort of spatial forecasts of Arctic sea ice concentration, at least at sort of monthly and longer timescales. However, having said that, it is quite possible that certain regions might have skill at these seasonal timescales. And since 2016, we've also been including just the Alaskan seas forecast, which is the Chukchi, Beaufort, and Bering Seas altogether. And you can actually see that it's a very short sample size, but there does seem to be decent skill, well, at least some skill. So we're you know, very intrigued when we made this plot, and so we're kind of looking forward to seeing in the future, like if this persists, or you know, if these forecasts have some promise. Okay, so the summary so far, I'd say that the sea ice outlook has been a successful enterprise in terms of creating this network of sea ice forecasters and fostering kind of collaboration and you know, a lot of networking. And we've learned a lot about sea ice predictability and the current state of sea ice forecast. However, the forecasts are still relatively unskilled. And this is a bit of a mystery because when, you know, a lot of these, or some of these groups that have submitted forecasts to sea ice outlook, they've made their own hindcasts, you know, where they've done retrospective forecasts over the last 20, 30 years. And they get skill, you know, decent skill at these sort of monthly to seasonal timescales, right? So the skill in the sea ice outlook is lower than that, and we don't know yet why. And it's certainly lower than the perfect model forecast, right? That definitely show pretty good seasonal skill. And so this leads us to, you know, to that kind of next question in bold is, well, what is the optimal way to improve forecast skill moving ahead? Do we focus on the initial conditions? You know, do we try and get a better estimate of what the sea ice thickness and sea ice volume are at the end of spring, early summer? Is it more model physics and process understanding? And I would say that I think we're living a bit of a kind of golden age of sea ice science, that there's just so many exciting opportunities to focus on both in terms of observational campaigns or modeling efforts, right? Now, I did promise I would talk a little bit about the future. Not very much, because so right now we have a current pending proposal at NSF that would get us through or, you know, fund the next few years of this effort. We want to expand the sea ice outlook to winter forecasts. We've had a lot of stakeholders. For example, Alaskan crabbers, they operate in the Bering Sea in late winter, early spring, and you know, we had an economist be part of SIPIN, communicate with them and say, well, you know, we had this kind of forecast in that time period. They might be pretty useful. So we want to start inviting the community to contribute forecasts in the winter season, focus more on regional, and then start to focus more on the research questions. And to do all this, we want to have a centralized data portal where we have observations and forecasts kind of like more seamlessly integrated in one place. And so to focus on the research questions as the first step, we've invited a collection of hindcasts, so retrospective forecasts, Mitch Bushhook has led this effort, and so far it's been really successful. We've had 33 models, and it's almost, I think it's 17 dynamical and 16 statistical, so split in between the two. So a lot of the contributors, they've now gone and done a hindcast with the same model version. Because a problem of the CIS outlook is that the same group might use different models in different years, so it's really hard to kind of compare the skill across different years if you don't have the same model. And basically with this hindcast, this is kind of a preliminary figure on the left. This is the skill, the root mean square error. The different colors are the different models, but I want to show you the attention, or bring your attention to the black lines, the dashed black and the continuous black. That's the median forecast of the dynamical and statistical models, and compared to the right, you can see that they're doing quite a bit better, but there's still quite a bit of spread. So I will leave it at that, and maybe I'll actually leave you with the kind of the very last slide. This is some of the objectives we're thinking for SIPN 3. But thanks for your attention.
Okay, great. We'll entertain questions if you go to the mics. I see that Helga Gosling actually sent one on the chat here, so I'll just read that. Cool talk, Ed. Are none of the groups applying any calibration to the forecasts before submitting? If so, is that maybe intentional to have a cleaner comparison, and should calibration be considered more in the future?
No, they definitely do calibrate their forecasts, but each contributor decides how to calibrate them, right? But if your mean states say off by 1 or 2 million square kilometers in your hindcast, we definitely expect them or hope that they take that into account. If the trends are off, they do bias correction of the trend. But the exact way they all calibrate is, we don't have a standard, right? We kind of started this exercise very kind of democratically, like sort of everyone do what you can or want, right? Because we realize that, these are all kind of voluntary efforts, and, we're sensitive to that. But that was partly why we invited the anomaly forecast, right? To be like, do they get better? Or at least does that spread reduce a bit when, and we're trying to make contributors think about sort of their own biases and correction. But yeah, hopefully that answers.
Yeah. Lorenzo.
Thanks for the talk, Ed. So, do you have good examples of groups that took this CIS outlook occasion to improve systematically their system year after year? So have you observed sort of systematic, even if small, improvements? Or do you have the feeling this became a bit something that you do every year and that groups are not really working on the forecast
well,
models?
that's a really good question. It's kind of two parts to it, right? One, so we had a workshop in 2021 where one of our main questions to the community was, is the CIS outlook useful, right? Do you want this to continue? And pretty much everyone said yes. Like, this is a great motivation for us to produce these forecasts and to be able to compare them with other centers. And then there's the second question in terms of how the skill has evolved. So this is what's really hard to, or almost impossible to assess with the current generation or the current CIS outlook, is because even if you look at the same center that submits forecasts, they, almost every year, the model version is different because they are incorporating, new physics or new observations. So, and we don't ask for a hindcast every year, right? That's something they might do sort of privately in-house. But that's what we're hoping to do a little bit with that hindcast that Mitch Bushhook's leading. Yeah, but great question. Johnny?
Hi. Yeah, big fan of the data portal. It's like a really nice one-stop shop for looking at all of the forecasting systems and things. And I was wondering if that's planned to be continued as part of this proposal.
So the data portal we had for SIPN 2 was part of a parallel grant. It was actually, I co-led it. It was at the University of Washington with Cecilia Bitts. And thanks for being a fan. It's a little bit broken now because the grant finished, so we don't have the money to upkeep it. But basically for SIPIN 3, we want to export all that infrastructure to actually a new group in Oregon is going to lead that. But that's the idea, right? That everything's at the same place and the data are going to be also publicly available so that I think the user can do some analysis. And so it's going to be a one-stop, you know, whether you're interested in what the CIC is doing now in observations or whether you're interested in the forecast, it's all going to be in the same place.
Great. Thank you, Ed.